our today. Let's start class today by trying to look at the matter of change of subject of formula. And I'm going to give you a few questions and I'll see how you react to this. So question number one, review questions. Number one, x plus a equal to b. You have to make, in all of these questions, you have to make x the subject of the formula. So x is the subject of the formula you have to worry about in all of these questions. Then number two, then number three, then number four, and then number five, so 5 questions to test how well you have, at least at an elementary level, to see how well you remember these concepts we have treated so far. So I'm going to give you about 5 to 10 minutes to handle that. Once you're done, you let me know. Okay. Figure out. For number one, it says x plus a equal to b. I don't need a, so x will simply be equal to what? B minus a. Is that what you got?
Yeah.
Number two is ax plus bx equal to c. If you look at, I have x here, I have x here, which means I can factor x out. So this will be x into a plus b equal to c. And I don't need a plus b. And what is a plus b doing is multiplying x. So if it crosses the equality, it will be dividing c. So x will simply be what? C over a plus b. Was that what you got?
X equals c over a plus b, yes.
X equal to c over a plus b. Was that what you got?
Yeah.
All right. So go to number 3. We have x over 2a plus x over 3b over 3a equal to b. I have x here, I have x here. Look at the denominators. I have 2a, I have 3a here. So I need to apply what? My concept of LCM. To eliminate 2a, I need to multiply by 3a. To eliminate 3a, I need to multiply by what? 3a. So whatever I'm going to do to this, I must multiply the equivalent LCM here. So it means x multiplied by 3a plus x multiplied by 2a must be equal to the LCM of this, or the LCD as it applies to fractions. That will be 6ab. So this will mean 3ax plus 2ax equal to 6ab. I can add this. We're going to have 5ax equal to 6ab. I don't need 5a on the left-hand side, and that will mean that x will be equal to 6ab all over 5a. A we go with a, and I'm going to have that what? X will be equal to 6b over 5. Was that what you got? Sorry,
yes.
I think I made a mistake here.
No, it's supposed to be 6ab over 5.
No, I think I made a mistake here. I've just discovered it. Now this will be 2. This will be 2, 3. Sorry about that. Did you notice that?
No, I noticed at the end when you didn't get 6ab over 5.
No, that's the reason I didn't get out, because the LCM is 6ab. If the LCM is 6a, if 6a is applied here, I'm going to have 3 left. So that's what has happened here. So I didn't apply that. Please, whenever problems are solved, if you have any question, don't always assume that because I'm the teacher, I'll always be right. No. Sometimes what I provide as a teacher is direction. So it's always good that if you notice that maybe I've done something that is not right, draw my attention. And if I'm wrong, I should be able to detect where I have made that error. All right. So let's look at the next one. A is equal to 2b plus 3x over 3b minus 2x. Now, this is a denominator dividing this. So what will it do to this to multiply this? So A will then multiply 3b minus 2x, and that will be equal to 2b plus 3x. Remember that what I'm looking for is x. So I need to open this part. I need to open this part out. I need to do what? Open that part out. So that will be 3ab minus 2ax equal to 2b plus 3x. Are you seeing that? So I need to bring the x to one side and then bring the other terms to one side. Now, this is where your sense of judgment is tested. This x is already positive. This is negative. So the rule says make the unknown, question of the unknown, what? Positive. So this will now be 3ab minus 2b equal to this one, which is positive, and bring the other one, which is what? Negative, which makes this one what? Positive.
Yeah, well, I also know something. It's like possible to make it like a negative and like solve it, and then at the end change it to positive, but it's much easier if you just do it like this.
Fine. Yes, you can do that, but my experience in maths have shown that students have a strong tendency not to handle negative well. So my school of thought will say that deal with and avoid negative as early as possible. That's the reason for my method. You can use your method and still get the answer. But I have a theory that deal with the negative as early as possible. So if you use your method, you still get the same answer. If you're comfortable with that, fine. All right, so this will now be what? 3x plus 2ax equal to 3ab minus what? 2b. So look at this, I can factor what out? X. And I'll be left with 3 plus what? 2a equal to 3ab minus 2b. So I don't need 3 plus 2a on this side. So x will be what? 3ab minus 2b all over what? 3 plus 2a. Now, notice that you can go further to say b into this, but I've not bothered myself on that. I only bother myself if I'm taking an exam where I can't find this option there, then I need to go further. I'm going to have that b into 3a minus 2b all over what? 3 plus 2a. So that's what you're going to have for that question. So the last one, x over 2 square root of a, square root equal to a, square root of x over 2 equal to a. Now for a question like this, I need to clear the square root. The opposite, the antonym of a square root is a square. So x over 2 will be equal to a squared. The antonym effect is transferred to the left hand, to the right hand side. The antonym effect is transferred to the right hand side. So if this were square root, notice that the antonym effect is transferred to all on the other side. If it's affecting the left hand side, when you transfer the antonym, it must affect everything on the right hand side. Okay, that's understood. Then x will be equal to, I don't need this here. What is it doing? It is dividing. So it will be what? 2a squared. And that takes care of that problem. Is that okay?
Yeah. Wait.
All right. So let me give you one. Let's take a few more examination level kind of questions and see how you fare with them. So let me give you more, so with greater level of difficulty. Now look at the first one, number 1. P equal to N plus 2 over D. I'm going to bracket, make D the solid of the formula. Then look at number 2. K is equal to BRT over V minus B. Make B the summate of the formula. Number 3. C is equal to mu squared minus 5mg. This mu squared is divided by K. Number 4, which would be S is equal to, okay, I have to make M the summate of the formula here. K rather, make K the summate of the formula here. Then the next one, S equal to WD over H into H minus D over 2. Make H the summate of the formula. And then the last question, those are these ones are of little bit of higher level work. The last question is I equal to E all over the square root of R squared plus W squared L squared. And we're required to make R the subject of the formula. So let's see how you fare with these ones. All right, so let's look at number 1. P is equal to N plus 2 over D. So how do you solve this? Remember that the object is D. Now, I want to teach you a very interesting technique that will shock you now. Please watch carefully. There's one very funny thing I'm going to teach you. If I teach you equations with fraction, I'll teach you that technique. The way I teach it, I try to see how you can get your answers fast. The concept of balance also applies to what you do to left and right hand side. Now, I can turn this. If I turn this, I must turn this. So P could now be 1 over P, and D could now be what? D over N plus 2.
Wait, I thought you only do that when there's exponents, a negative exponent.
No, that's why I'm trying to teach you something now. The concept, see here, more often than not, when we solve mathematical problems, we limit ourselves. We actually limit ourselves in terms of what we can do as mathematicians. The rule says balance, balancing technique, which is something we teach here in grade 8. What you do to the left-hand side, you must do to the right-hand side. So let me take you back a little so that you understand what I'm doing. This P is also P over 1, is that not? The reason this is P, but it's standing over 1. And this is what? N plus 2 over D. So applying my concept of balance, I turn the left-hand side. So if I turn the left-hand side, I must turn the right-hand side. So at this point, I'm seeing D as a numerator. So what don't I need? I don't need the denominator. So if the denominator leaves this corner, it's going to be a numerator here. So D. So N plus 2 over P will be equal to D, meaning that D is equal to what? N plus 2 over P. Because remember, it's like a game of chess. The less moves you make, the better your chances of winning. Sorry, that's the way I solve maths. I try to reduce the work we do.
What? Wait. Can you? I have a question. Can you say that it could be D equals P parentheses N plus 2?
D equal to what?
D equals P parentheses N plus 2.
No, the P will divide both N and 2.
No, but like, what if you what if like in the original equation, what if you just move, you just like, since the one on the right is division, you can just multiply it by the P and then just bring the D to the right.
Let's perceive what you may have done. Most math students will do this. Is that not?
Yeah.
Is that not?
Yes.
Yes, and I think in this setup, you would argue and say this is a shorter method. Is that not?
Yeah.
But that's not always the case in maths. The objective is not always about the short method. It's about exploring and stretching your thinking. Because there are problems that will require you to apply this knowledge and you are faster. So when we solve maths, I don't restrict you. I want you to juggle, play with the ideas, play with the concepts. Then in the exam setup, which is like a football match, you cannot decide the formation you want to do, whether you want to have a 4-man defense, a 5-man defense, a 2-man defense. Pep has done that before. In Man City, he had a 2-man defense and a crazy 5-man attack with, I think, a 3 midfield arrangement where people can tweak and be crazy with concepts. But the idea here is, my responsibility is to open you to concepts and to possibilities. Your responsibility is to decide what you do in an exam setup. All right, so we're done with this. So let's go to the next one. Number 2, that will be K equal to BRT all over V minus B. I was told to handle B. Now, because there is B and B here, you must clear this denominator first.
Wait, you're just gonna cross it out, right?
So we open this bracket.
Wait, I'm so confused what you just did for like a second.
What is this?
No, because the BRT over V minus B, aren't you just gonna cross out the B like from both sides? You're gonna be like, oh, no, RT over V.
Very good. Now you have raised a very important issue that a lot of students seem to make mistakes at. Now look at this. BRT over V minus B. The only way you cross out is if it is a factor. B is not a factor of V minus B. B can only be a factor if I have BV. BV means what? B is a factor. So in this setup, I can cross out. But because B is not a factor of V minus B, I can't cross out. So the first thing I want to do is to clear the denominator. Does that work? Any reservations?
No.
All right, so this will be KB, KV. I don't need B in this part. I see that. Then I can rewrite this. Then I can factor B out of this. B is common to both sides. At this point in time, B is multiplying this, so I don't need this.
You can just divide now. Yeah.
That's it. So that's the solution to that one.
Okay, I have a question. Is there a specific reason why you put the RT plus K? Is there like in math you just have to put the double digits first before the singular? No, in the final answer.
This one.
Yeah, is there a reason, like,
Okay,
or you
okay,
just
no,
did it
you
because
can have this.
okay,
That
so
was
there's no rule in math where you have to put the ones that are combined together first.
no. Let's very interesting question. I think I like the questions you're asking tonight. So let's look at this. If I say a 2 plus 1, what's the answer?
3,
1 plus 2, what's the answer?
2,
2 plus 1, what's the answer?
3,
1 plus 2, what's the answer?
3.
Is it the same answer?
Yeah.
So what it means is that as long as I'm adding the terms, the order in which I write them is not necessary.
Okay.
You get it?
Yeah.
As long as I'm adding them, the order in which I write them is insignificant. Does that flow well with us?
Mm-hmm.
All right. Number 3, T is equal to M U squared over K minus 5mg and K. We're told to look for K. Now look at where you have K. K is only dividing mu squared. So it means that I can actually do away with this part. So I'll move that one first. So that will be T plus, because it's negative, encountering equality, I transfer its antony. Are we seeing that?
Mm-hmm.
So what do you have here? This T, now let's upgrade on our thought a little. This T will come here, and that will be equal to mu squared over T plus 5mg. Can you relate with that?
Yeah.
Beautiful. So what I did was that I just, there's a movie back in the days featuring Eddie Murphy, I think. It's called Trading Places. Your dad, if you ask your dad should know about that movie. Trading Places. And in grammar, it's a figurative way of saying where you put one person in place of another position, like swap of positions. So that's what has happened here. Sorry, I watch a lot of movies, so more often than not, I can relate. The way I relate to math is based on the movies I have watched. All right, so I don't know that I've confused you, or you can relate with that.
Yeah. Yeah. No confusion.
Okay, all right. Right, so that will be the final answer. So you discover that with what we've done so far, we can say you are now a guru at change of subject of formula. So pick any change of subject of formula, even to university level, you can solve it now with what we have done. So anyone you get and you cannot solve, bring it to me. That means I did not teach you well. Number 4. S is equal to WD over H into H minus D over 2. And we are told to make H the subject of the formula. Now, look at this question very well. In this question, because you're having H here and H here, your first and most effective way of solving this is to open up this bracket. So you see that in solving this problem, decision making is important. So this will be S equal to this, that will be WDH over H. In an exam setting, I may not do this, but I'm just doing it so that you see what you can relate with my thought process. Minus WD d times d squared over 2 times h is 2h. I see that. So h will cancel h. Now, at this point, I'm going to have s equal to what? wd minus wd squared over 2h. Now, this is negative. Remember, our golden rule is that the coefficient of the unknown must be positive. So I will move this trading places, concept of trading places now. This will come here and this will go here. So I'm going to have wd squared over h over 2h being equal to wd minus s. Minus s. And with that, look at what's going to happen now. Because remember that I'm trying to look for h. So I'm going to apply what I did before, the concept of what happens to left hand must happen to right hand. So I'm going to have 2h over wd squared equal to 1 over wd minus s. So at this point, this one can equal to wd squared all over wd minus s. I don't need 2, so 2 will divide this. So h will now be what? wd squared all.
Hello? Hello? Hello, can you hear me?
So what you notice is that this 2 is multiplying h, so to divide the left hand side. So it will be 2 into wd minus s. Is that what you got?
Wait, 2 WDS? Oh, I think what I got was just completely different. I got H equals -2 H equals -d squared W over 2s minus 2dW. Oh, I'm seeing now. It's the same thing. The same thing.
You're right.
Yeah.
You're right. I understand what's happening. Now, to verify whether what you have done is correct, we would expect the content, these things to turn. So you had S before W, am I right?
Yeah, and I distributed the 2.
Fine. But you have to be careful there. So these are your possible answers here. You can have negative WD squared over 2 into S minus WD, which will be negative WD squared over 2S minus 2WD. Is that what you have?
Yes.
You're correct.
No, I had like -d squared. -d squared W for the numerator.
Okay, fine. Okay, it's okay. So you brought the D squared first before the W.
Yeah.
Okay, it's okay, fine. You're also correct because there is an aspect of this math that says you must write in the order of the letters of the English alphabet. A golden rule in algebra is that you write in the order of the letters of the English alphabet. I'll come again. We write in the order of the letters of the English alphabet. So if you have applied that rule, you're spot on. You're okay with what you've done. All right, so let's go to number 5. Number 5, and that will be I equal to E all over the square root of R squared plus W squared L squared. All right, so let's see how we're going to solve that. Let's see how we're going to solve that. Let's see how we're going to handle that. All right, so we're going to have that. We're told to look for what? R. So the first thing I want to do.
Wait. You never gave me a number 5. It ended at number 4.
No, there's a number 5.
There was a number 5.
This is number 5.
Oh, I did not see that. Oh, number 5 was above the number 4. Oh, I didn't do number 5.
So the first thing you want to do is to deal with this part. I into the square root of r squared plus w squared L squared equal to E. So I don't need I, so I'm going to have the square root of r squared plus w squared L squared being equal to E over I, because if this is multiplying this on the left-hand side, we would expect it to do the division thing. Now, this is square root. If I transfer square root by concept of transfer of antonym, I'm going to have that this will be r squared plus w squared L squared equal to all bracket E over I all squared. Right? So the next thing will now be r squared will now be equal to what? What I have on the left-hand side will be E squared over I squared. I can open this up. Minus W squared L squared. So what's the next thing I will do? I'll find the square root. I'll transfer the antonym. This is squared. So when I transfer squared, it becomes square root. So R will be equal to the square root of what? E squared over I squared minus W squared L squared. That clears off that answer. So sometimes you see the problem looking big, but they are just big for nothing.
Wait. So the answer is I got I got something completely different from what you got, but I think it's gonna be the same thing. I don't know what I got. I got R equals radical E squared minus I squared W squared L squared over I.
Over I squared.
Oh, I didn't get over I squared. I only got over I.
The denominator.
Just over I, that's it.
That's this now.
Yeah, is it correct?
Very correct.
Okay.
So I can say without a doubt that we are now the keepers of change or solid of formulas. So I trust that no matter how they set the question, you should be able to answer. All right, I'm going to send something to your WhatsApp now with my other line. I want to see how well you understand equations. So we're going to clean this off. We're going to stop the recording, and then we'll try to look at equations now. Remember that we said that change or solid of formula is an aspect of equations. In equations, we are looking for an unknown. In change or solid of formula, we are changing emphasis from one unknown to another. All right.